This is Algebra 2, Unit 2, Lesson 1, Introduction to Functions. To start out this year, we're going to start out with the function notation that we learned way back in Algebra 1. So we want to make sure that everybody understands what a function is and how it's interpreted. So let's start with the definition of a function. A function is any rule that assigns exactly one output value or y value for each input value or x value. So you see them as equations, graphs, and tables of values. The input is called the independent variable. The x value is independent. Because when you plug in an x, you want to get an output or a y. Now, x can change to as many things as you want it to be, and whatever you put in for x will affect what your y is going to be. So the y value depends on what the x value is. So let's look at an example of a function. An internet music service offers a plan whereby users pay a flat monthly fee of $5 and can then download songs for 10 cents each. So what are the independent and dependent variables in this scenario? Well, let's think about this for a second. If you're downloading songs, you're going to pay $5 and then 10 cents for each song that you're going to put in. So what's going to change every time is the number of songs. That would be the independent variable. So the independent variable would be the input. How much you're going to pay depends on the number of songs downloaded. So the input will be the number of songs. Okay, the output or dependent variable, which is the output, would be how much you're going to pay. It is going to be the total cost you're charged. So that depends on how many songs you're going to download. So the output is the cost is dependent on, is a function of the number of songs downloaded. So you can see that this is a function based on the number of songs downloaded, your input, and that will give you how much it's going to cost. So here's a table with some of the independent values that we may see. All right, so if you don't download any songs, well, you still have to pay the $5 fee, so that's going to cost you $5. Okay, if you buy 5 songs, you're going to have to still pay the $5 plus 10 cents a song, so that'd be 50 cents more for songs, so this would be $5 plus the 50 cents, and that would be the total charge. For 10 songs, you'd have to pay the $5, and then 10 times 10 is $1, so that would be $6 that you'd have to pay. And then for 20 songs, you'd have to pay the $5 plus 20 times 10 is $2, so that would be a total of $7. So you can see how much you're charged is a function of the number of downloads. So you have to know what your independent variable is to figure out what your charge is. Okay, so let the number of downloads be represented by the variable x and the amount charged in dollars be represented by the variable y. Write an equation that models y as a function of x. To get your cost, y equals, you have to figure out what your independent variable is and how it's applied. It's $5 plus 10 cents per song. So it's 10 cents per song plus the $5. Y is a function of x. You need the x to find the y. All right, so now that we have our function, let's remember how to graph this. So based on this equation, let's do a graph of this function. Now we can just plot these values right here. 0, 5, 5, 5, 50, 10, 6, and 27. We get a very respectable line. All right, let's do a little calculator review because we haven't done that at least all summer, and make sure that we know how to use the calculator table. Okay, so remember that our equation was y equals 0.10x plus 5. All right, so first of all, just before we even start, what would be the y-intercept of this? At 0, it was at $5, so we know it's going to start right there. Okay, now the slope of this is going to go up by 10 cents, but you notice here that your scale, this goes from here to here is 250, so that means that each of these is going to be 50 cents. All right, so each line is 50 cents. So going up by 10 isn't going to be that fun. So what we're going to do is we're going to produce a graphic function for all values of x in the interval between 0 to 40. All right, so they want us to go from 0 to 40. Now notice this is marked off as 10, 20, 30, 40. Okay, so why don't we just find the values at those values? So let's go, we know 0 is at 5. All right, we want to go 10, 20, 30, 40. All right, so here's what I'm going to do. I'm going to get out my calculator. I'm going to go to y equals. All right, remember your y equals screen here. Okay, you put in 0.10 x plus 5. So there's your equation. All right, now my table that I have, you press second and graph and go to your table. This is all by ones, but I want it to be by tens. Well, if you press second and the window key, it says table set in blue up there. All right, my table is starting at 0. Now delta table, this triangle right here, means how do I want to go up by? Well, it's set as going up by ones. I want to go by tens. So there's my tens. So let's go ahead and look at our table now. Second table. Notice it's going by tens. So 0, 10, 0, 5, 10, 6, 27, 38, 49, all set to go. All right, so this was 6, 7, 8, and 9. So there's my values that I have. So I just rearranged my table to fit my values. Okay, so if I want to graph this, 0 is at 5. We already did that one. 10 is at 6. So if this is 10, 5, 550, 6. 20 is at $7. So there's 20 is 5, 6, 7. Be right there. 30 is at 8. So there's 750 and there's 8. And then 40 is at 9. All right, so there'd be 9 right there. Okay, so I've graphed this from 0 to 40. All right, I draw my nice neat line in here, and all of those will line up because this is a nice linear function. There we go. Okay, so that is the table that we just did of this function. We can actually go to any place on this line and figure out your price. Remember we said that 5 cost $5.50? Well, if we go to 5 here, this is going by 2s, 2, 4, 6, 8, 10. So 5 would be right here. It's right at $5.50. You can see it goes right here. So I can pick any value on this table out to do that. All right, now my next exercise is showing which one's a function and which one is not. All right, so what we want to do is draw a vertical line whose equation is x equals 3 on both graphs. Okay, so x equals 3 would look like this. This is 1, 2, 3, x equals 3. That's x equals 3 right there. And then x equals 3, 1, 2, 3 would be right there. That's x equals 3. So for x equals 3 on both of those graphs, give all output values for each graph at an input of 3. Okay, so remember your input is your x value, so x is going to be 3. So if I look at relationship A, I hit the graph here, and I hit the graph here. So I have the point 3, 4. That's this point right here. And I also have the point 3, 1, 2, 3, negative 4. So my output value, y is 4, and y is negative 4. All right, for my relationship on B, down here, when x is 3, right here, y is going to be negative 2. So that means that my output value is y equals negative 2. Okay, so which of these relationships is a function and why? All right, now remember the definition of a function. For each x, there is only one y. So is relationship A a function? It is not. It is not a function. Okay? X equals 3 has 2 outputs. It has 2 different outputs. So this is not a function. All right? It's touching here and here at x equals 3. So it is not a function. Each x equals 3 actually has 2 different outputs. Relationship B function. If we look at this graph right here, and I pick any x value on this graph, there is only one output. Every x has only one y, no matter what it is. Now, notice when we drew this line, it doesn't matter where we draw the line. If you draw a line, a vertical line, and it hits the graph in more than one space, it is not a function. That is called the vertical line test. All right, so if you draw a vertical line on a graph, if the graph is intersected only once, it is a function. Okay? If the graph is intersected more than once, it is not a function. And you can draw the vertical line anywhere you want. So if I want to draw a different vertical line, I could draw it here, I could draw it over here, I could draw it down here. If you hit the graph anywhere with the vertical line and you only hit it once, it will be a function. If at any place on the graph you hit it more than once, it is not a function. So the vertical line test is very, very important. It tells you if a graph is going to be a function or not. All right, the last part of the notes here is the graph of the function is shown below. All right, now what we want to look at is some parts of a function. The function's y-intercept. That's where it crosses, the graph crosses the y-axis. All right, so where does the graph cross the y-axis on this graph? Crosses it right there. The x value is 0, the y is equal to 1. So the x value is 0 on this one. So when x is 0. Okay, so the y-intercept is at y equals 1. Between what two consecutive integers does the larger x-intercept lie? The x-intercept crosses the x-axis. All right, so where does this cross the x-axis? It crosses it here and crosses it there. Okay, so what two consecutive does the larger x-intercept lie? Well, this one lies between the integers 0 and 1. Okay, this one lies between 3 and 4. So we're looking at this one right here. So between x equals 3 and x equals 4. All right, so I'm going to stop there because I want to show you a couple other calculator tricks on the graph in class the next day. So make sure that you know with this, and I'll actually show you where to find this exactly, how to find this exactly crosses as well. Okay, so that's the end of the notes for today. We'll finish the notes in class tomorrow and then have the homework on this stuff.